Welcome to a lesson, Dr. Powell. Let's take a look at how we can find the minimal polynomial of this matrix by using the characteristic polynomial. So what we're going to do is we compute the characteristic polynomial. We're just going to use a cofactor expansion when we look at the following matrix. So we're going to take the negative of this guy um, and then just put x's down the diagonal. So like add x's to the diagonal entries. So essentially, I can just fill out the entries like this, and there's a 0 right here. So let me erase this so I have you can see that. A 0 and an x minus 1. Okay, and this guy right here, so this is a separate entry than that. Okay, so this is a 3 by 3 matrix like that. Kind of see the entries like, all right. So we take a cofactor expansion on the bottom row to take a determinant of this. So this multiplied by the determinant right here. So that would be x minus 1 times, and that looks like x squared minus 1, which actually factors as x minus 1 times x plus 1. All right. So we're taking a look at this. It's in factored form. And the nice thing about the relationship between the minimal polynomial and the characteristic polynomial is that they share the same irreducible factors, meaning things you can't like factor any further. So the guys right here, so this is x minus 1 squared x plus 1. So the irreducibles would be x minus 1 and x plus 1. So the minimal polynomial shares those as factors too. So really the options, there's only two options for the minimal polynomial. It's this times this, or the whole characteristic polynomial itself. So we just have to check. We already know the characteristic polynomial is equal to the 0 matrix when we plug the matrix in. So we just basically have to check this right here, which is the same thing as this is x squared minus 1. So we just have to compute x squared and then subtract the identity and see if and we get the 0 matrix. So basically, we just have to check to see if x squared, so the matrix squared, is the identity matrix. That's really it. So to take the square of this, we can go column by column. We can take this first column and think when we plug that into the matrix, it's like it just picks out that column. So 1, 0, 0. This guy, when you plug it in the matrix, picks out that column. Oh my goodness. And this one, I plug it just, oh, it is. Hey, that means that this guy right here is the 0 matrix. And since it's smaller than the characteristic polynomial, and these are the only two options using that rule, this must be the minimal polynomial right there. Thanks for watching.